Hello everybody, I'm Nick and in this video I'm going to show you how you can start using pagination in your REST API in ASP.NET Core. The approach I'm going to go with is very simple. There are many ways to go about it, but I'm going to go with the simplest and it's usable as much as any other method. What I want to explain is why do we need pagination. The reason is quite simple. We don't want to return everything in a single response when it comes to response with multiple items in the response, because the response can get huge, and if you have like tens of thousands of requests in a single response, that's a lot of data going over the wire, and you might not want to allow the users to do that. So instead of returning everything in a single response, you might want to return them in essentially pages. So what you see in any website that has any sort of pagination. REST APIs work very much in the same way. The first thing I need to do in this approach is to create two classes, and these will go in the contracts. The first one I need to create is called a response, or it could be called API response, but I'm going to go with response because this is an API, so it's implied. And the way I want it to look like is I want to have a generic type T parameter, and then I want it to have a parameterless constructor and one that accepts this T data, or in fact the better name is T response. And we are going to have this property here called data. So data equals response. And with this response, we are going to wrap all the things we're returning in our API. So instead of returning the object itself, so in this scenario, if I go to the post controller, instead of returning a list of response or a post response or any of that, I'm going to turn a response that contains that. And let me just quickly do that and show you what I mean. So we're going to say new response, and the type is this type here. And here we go. And we need to do the same for all the other things we're returning, except the errors. This is only valid for the good responses. So here we go. And in fact, I can actually copy that here. And I think it's the same across the other things that return a response. So yeah, and also, oh, this is created, so I don't copy the whole thing, I'll just copy this bit. So now everything in our API is returned into this object. Let me run this and show you how this looks like. So here I have our API and I'm already authenticated. So if I just return now all the posts, you will see that they're returned into a top level data object. And that is the same with any other response in this controller. And I will do the same for the tags controller as well. Now, why did we do that? We did that because now, let's say I want to add some other metadata stuff in the response. I can do this in this very top level without actually affecting the response contract itself. So people that need to use this will just pass this data object as our response object, and then they can get other things from the top level. And this will become more clear on why we're going to do this now that I'm going to actually add the paged response. So we'll need to create another class as well, again in the contracts, and this will be called paged response. I've seen people inheriting in the contracts. I think that's a very bad idea. Let me just stop running this, because you're coupling your contracts with each other, and if you change one, like the base one, you might accidentally have a knock-on effect on the rest. So I recommend not doing that. Again, we're gonna have a parameterless constructor because our SDK will need to use this, and it won't be able to use the constructor to deserialize automatically. And then I'm going to create this constructor, but I'm gonna use an enumerable here of T, because a paged result implies that we have many items in the response, not a single one. So we have the data here, and again, I'm going to make the same enumerable of T here, and I'm gonna call it data again, and I'm gonna say data equals data here. But on top of that, I'm going to add a few other properties, and these will be an int which is nullable called page number, another int nullable called page size, a string called next page and another string called previous page. Now that we have this class, we can actually take it and use it in this one case where we return many responses, so many posts, and this would look something like this: page response of post response. So now we have this page response, which also has all these other values in the response. So if I run this again and I execute this again, you can see scrolling down that we have these null values here, and they're null because we're not actually setting them. What we need to do at this point is add two query string parameters: page number and page size. This will indicate which page we're retrieving, and when we do that, we will get the page number, the page size, and the response, and we're also gonna get a pointer to the next page and to the previous page. So the SDK, the client that's using this, can actually do pagination in their front end. So let's see how we can do that. The first thing I need to do is I'm going to create a pagination query. So I'm gonna go to the requests and I'm gonna create a new folder and I'm gonna call that queries. And in there, I'm gonna create a query class, and that will be called pagination query. And it's gonna have a constructor, and we'll see what will go in here. In fact, it will actually have two constructors. We will need two properties. We will need an integer named page number, and we're gonna need another integer called page size. And in here, one of them will just set those values, so page number and page size. But the other one, we will just default it to some values, and these will be page number equals 1, so we always by default want to get this first page, and page size, and here you need to default to a value that you deem acceptable. I'm gonna go with 100. This is specific to you, your case. If you can handle more, you might want to default it to more, and you might also want to limit them to here. So say something like, if this is more than 100, then return 100, because you don't want them to just say, give me 1,000,000 results back. That's up to you, but here's how you can just default it. So with this pagination query now in here, I can actually go to the controller and I get all endpoint and do from query and use this class pagination query, and then just call it pagination query. And if I import it, now .NET Core is smart enough to actually recognize these two values by name, page number and page size, and allow me to specify them in here. At this point, since this is a contract, I actually need to create an equivalent domain object to actually map this contract to. So I will go to domain, I will create a new class, and I will name this class pagination filter. And this class will have two properties, int page number and int page size. So with that created, I'm gonna go ahead and create a mapping profile, and this mapping profile will be from request to domain. So I'm gonna create a new class because that doesn't exist. So request to domain profile, and this will need to extend the profile class. And in the constructor, I'll need to say create map, and we are mapping from the pagination query to the pagination filter, and that's all we need to do. So in the post controller now, I'm gonna split this up a little bit to make it a bit more readable. We have our posts response, which is mapped to the object, and then here we will have our pagination response equals this, and I'm gonna copy that mapped value from this to this and return it here. So roughly this is what this should look like, but at this point we will need to pass our filter to this get posts async method. The way to do that is we're gonna do a pagination filter class, and we're gonna say mapper.map, and we're gonna map this fella here to the pagination filter we just mapped in the profile, and we are going to pass that down to this method. Now currently it does not accept it, but we're gonna make it accept it. So pagination filter, now that it's a domain object, and we are going to add this in the implementation of this class as well. This goes here, and the way to implement this with Entity Framework is very, very simple. The first thing I want to do is I want to say if pagination filter equals null, because it could be null, and in fact let's just make it nullable by default, and I'm going to add that in the interface as well. Then we're just going to return everything. This will never be the case because we already set the value higher up, but let's just do it like this. So if it's null, just return everything. What we need to calculate is how much in the future to skip based on the pagination configuration. So I'm going to say pagination filter dot page number -1 multiplied by pagination filter dot page size. This is the formula to calculate how far we need to skip, how many documents we need to skip, how many files we need to skip in the database. And all we need to do is just say dot skip this skip amount, and then just take the page size. So pagination filter dot page size. And this is all the database stuff we need to do for our pagination. So being done with this service and closing all these others, it would be fairly straightforward to just at this point just return. So in here I have a paginated response, I have the posts, I could set all the page number and page whatever in here, and that will be all fine. But we also want to set the URIs, so the URLs to the next and the previous page. And this is just a nice feature to have when you design a REST API, because you make it very easy for the consumer to use. So what I'm going to do here is I'm going to create a new service, and this service will be called IURI service. The responsibility of this service, let me just turn this into an interface. The responsibility of this service is solely to just generate URIs from our API for different purposes. I'm going to create two of them. I'm going to create one for the get post by ID endpoint and one for the get all posts endpoint. And I'll show you why I'm going to create both of them. So the first one will be the URI get post URI, and here we accept the post ID, and the other one is URI get all posts URI, and in here we accept the pagination query, which defaults to null because you might not have it. At this point I'm going to create the implementation of this interface. So we're going to say IURI service, and we're going to implement the missing members. I'm going to add a constructor here because what we do need is to have a private read-only string which will represent the base URI of our API. Because remember, our API URI differs based on where we run it. It can be localhost, it can be on a different domain name, it can be on so many names. You want this to be dynamic, you don't want to hard code it. So I'm going to inject it, and I'm going to set it during DI. So I'm going to say base URI here, and I'm just going to set it to base URI equals base URI. And let me show you what we're doing. In this post controller, we have this created location URI thing. Now, this is too much for the controller to know to generate it. Like, ideally, you wouldn't want to have this here. And in fact, that's what we're actually going to replace first. We're going to say read-only IURI service, and we're just going to inject it through the constructor, and I'm going to get that, and I'm going to say that the location URI, I'm going to comment these two things out, and I'm going to say that the location URI equals URI service.getPostURI, and then we're just going to say post.id.URI. toString. And then this service will do all this for us. We don't need to have it here. I can just delete it. How will this method look like? Let's just implement it and I'll show you. It's simply one line. We're just going to say return new URI, base URI plus API routes dot posts dot get dot replace, and we're going to replace the token in here. So I'm going to replace the post ID, which is part of the URI, with the post ID. And that's it. And now we have a thing that can generate this URI for that endpoint. And you can make one method per endpoint in here for simplicity and for minimalization. I'm just going to create what I need, but you could create one for each. Now, the pagination one is a bit more complicated because we have this pagination query thing, but it's still fairly simple. First, we need the URI, which is the base URI. And then we're going to check if pagination equals null, then at this point just return the URI because there's no query string. If not, we're going to modify it and we're going to say modified URI equals, and we're going to use the query helpers class, which is part of .NET Core. So query helpers dot add query string, and we need to add it to the base URI. The name is page number, and the value is pagination dot page number to string. And then I also need to modify it again, and I'm gonna say again query helpers add query string. We're adding it to the modified URI this time. Let me just scroll this up so you can see. And it's page size, and then pagination dot page size dot toString. So here we go, and we're just gonna say return new URI modified URI. I'm sure there are cleaner ways to do this, but just let's do it like this for now. So we have something that can generate this URI based on the pagination filter, which is awesome because we are actually going to use it now to generate the next and previous URIs. The way to do this is very, very easy. So let's see what we got here. We have the pagination filter, we have the posts, and what we want to do now is we're going to say if pagination filter equals null, or pagination filter dot page number is less than 1, or pagination filter dot page size is less than 1. So if any of these values essentially is invalid because there's no minus page and there's no minus size, then at this point we're just going to say return, and let me just move those a little bit up. At this point we can just say return OK new paged response of post response of post response. I know that sounds weird, but we're just returning this list of post responses in a single page response. But if that's not the case, then we're gonna do some magic here. We first want to calculate the next page. So next page equals pagination filter. In fact, let me just rename this pagination filter to simply pagination because it's too long to show in this video. So pagination dot page number is equal or more than 1, then the URI service dot get all post URI, and then the query we're going to use is pagination dot page number plus 1 because we want to get the next page. So we're going to say what we have now plus 1, and then the page size is the equal size that we already have, else just null. So this is the next page, and we are going to do the same for the previous page, but we're going to subtract one. So I can just copy this. I can just say previous page if page number -1 is more than 1 because you don't want to go negative or 0, then page number -1 page size, and we also need to just toString this because the method will accept string. And now we have our previous and our next, and we can use that to create a new page response with all those values. So what we'll do is we're going to say create a new page response. We just scroll up, we're going to say data equals the object is the post response. The page number is the pagination number, which is it equal or more than 1? If it is, then use it, else return null. But because this is an integer, a nullable integer, I need to specify that. Same for the page size. The page size is pagination.pagesize. Is it more or equal to 1? Then pagination.pagesize. Else a nullable int. Then we have the next page, and we're gonna say, does the post response have any objects in it? Because if it doesn't, then there is no other page in the future. Else, just next page. So let's see how this reads. Do we have any objects in here? If we do, give me the next page. If not, return null because there's no next page. And the previous page is just the previous page. Now, you can actually tell that this is a bit of like too much code for this. So what I'm going to do is I'm going to create a new folder named helpers. And I'm going to add a new class in here. And I'm going to call it pagination helpers. And I'm going to move all this logic in there. Pagination building and all that can actually all go here. So let me just copy this. I would expect it to look something like this. Pagination response equals pagination helpers dot create paginated response. I'm hoping this is valid English. And then this accepts the URI service, the pagination itself, and the post response. And let's just create this method automatically. And we have our URI service, our filter, and this. Now this can actually be generic. So let me just paste what we copied here and replace as much as we can. I don't want to make this specific to the post response. It can be for any type of object. So for that reason, I'm going to change this to a generic t parameter. And I'm going to add the generic t parameter here. So we can just say any type of response can go here and rename this to response. And now we have our method here. Of course, we need to actually return as well. So return, I can just return here. I don't need to allocate the object. Here we go. So we have our object, and this object is in fact a paginated response of t. This looks way much cleaner. So there is a small thing I need to do, and that is in the startup, in the configuration, I'm going to go to the MVC installer and I'm going to add the initializer for the URI service. So add singleton URI, in fact, URI service, and I'm going to instantiate this. And don't get intimidated. It's actually fairly simple what we're going to do here. First, we need the HTTP context accessor to get the current request. So this equals provider dot get required service HTTP context accessor. Then we need the request itself, and this is coming from the accessor dot HTTP context dot request. And then from the request we need to get the absolute URI, and we're gonna concatenate a few strings here, and we're gonna say request dot scheme, and then we're gonna add these characters, which is part, like this is saying HTTP or HTTPS, and then these characters, and then the rest of it is a request dot host dot to URI component, and we're just gonna add a / at the end, and we're gonna return a new URI service with this absolute URI as the base URI, and this will guarantee that the URL that the user used to call us is what we get in the response whenever the URI service is actually used. So let's just see how all this hangs together. Let me just run this and show you what we did. So I'm now authenticated here. So if I now try to get all the posts, you'll see that we have two parameters. If I ignore them and I just say execute, I'm getting by default everything, but it looks like everything. It's really first page 100 items. But if I go now and say, give me page 1 and paginate every 5 objects, then I can execute this and I can get exactly 1, 2, 3, 4, 5. And then it tells me that here's the first page, first size. Here's a URL you need to call to get the next one. So if I do that, as you can see, we skipped the first posts and now we're here. Again, second page number, 5 page size, and there's another one, and there's a previous one, and so on and so forth. You can configure this even more if you want, but now we have this data object that has all these values, and then we also have all our pagination data. Of course, I will change the SDK to reflect those changes. You will find the code down below for that. I won't show this in the video because it's long enough already. This is all I had for this video for you. Leave a like if you like this video, subscribe for more content like this, and I'll see you in the next video. Keep coding.